now that I got you all smiling. So, we're going to talk about dependency diagrams next. And dependencies, actually, there's a reason why I want to talk about dependencies, because it will help you formulate better entity relationship diagramming. Because the next exercise that you're going to put together is going to deal with the concept of dependencies. And I don't want you to write entity relationship diagrams, you're going to be putting together dependency diagrams. And I'm going to show you what those are all about. And then I'm going to preview the next exercise, and then you'll start working on the next exercise, and then, which is kind of like the pattern for the rest of this afternoon. And then we'll have accomplished everything that we needed to accomplish for today. So this is lecture number 2, so I'm going backwards because I was doing 2A before, or 4A. So I'm now back to number 2, I believe, in this series. So if you're having problems with the first assignment, you haven't found all the answers, you'll have more information in this lecture. I'm kind of thumbing through it backwards, actually. It goes through the concept of the database approach, the views, the schemas, the hierarchies, the database terminology, utilities, and techniques. And it's kind of a lot of introductory information as well, which is in lieu of a textbook, so you don't really have to have a textbook for this course, actually, because there's enough reading. It's lecture number 2. It's marked, yes, it's number 2. It's on the bhacker.com website. Should show up here, number 2. That's what just this one is here. I think we were doing 4A and 4. We were just doing 4A last time. We're gonna hit 4B eventually. But lecture 2 is again kind of low level in the beginning, but it does contain something I want to show you, which is the dependency diagram information. So in terms of the database design process, what we're going to need to do, and this is basically going through the design process, and then what we're going to do for the second in-class exercise is design some databases using dependency diagrams. And then tomorrow we'll be hitting entity relationship and going into those. So you don't have to worry about diagramming tools yet, because you can't really use a diagramming tool for dependencies either. So the first step is to identify all the objects, the entities, the attributes, as we've seen before in some of these examples. Identify the dependencies, draw a dependency diagram, design the tables to represent the data items themselves, verify the design, implement the database, design the queries, and you're done. You have your application is complete, which is pretty much the process that we're taking for the database design. In terms of identifying all of the objects and entities, objects we know are entities, and entities are objects, so the question on that first assignment in class exercise was, the answer to that is they're the same. Objects and entities are identical. So, there's nothing very much to write for that, really, outside of the fact that they are the same. They are representing the same concept. It's just that object orientation talks about objects, not entities. So it's the same kind of term, different term used for the same concept, if you want to think of it that way. So attributes themselves have meaningful names, and they have descriptions associated with them. Attributes are sort of like the name, first name, last name, date of birth. Objects are the entities. The relationships we've seen before are kind of like one participates in some sort of a relationship with another entity in terms of that concept. When we start looking at dependencies, it's a different style of diagramming. And you see a lot of people that will do dependency diagrams instead of entity relationships, because dependencies helps you better organize the data from the start. And you can take a dependency diagram, turn it into an entity relationship one, but we're not going to really do that. Instead, we're going to take a look at dependencies today, just to give you an idea what it's all about, and then move right directly into entity relationship, and then in the future assignments just go for entity relationships. So today is really the only day you're going to get anything on dependencies or see that. And so a dependency, you're going to assume that there's a set of relationships between these data items. And it's called a dependency because one piece of data item depends on another piece of data item to give it meaning or to give it a relationship. So it's also part of the database structure in terms of the rows. So we have dependencies that usually turn into keys, where we get our primary keys from, which are our candidate keys come out of dependencies. So we take a bunch of data, separate them out into different piles, and then create dependencies among them so we can bring it back together. This is kind of counterintuitive if you think about it, but that's the way relational databases sort of work. I mean, if you think about it, if you put it all together and you can't link it together, but it's all together in one pile, it's hard to find something. But if you separate it all out into different categories and put a label on everything, then it's easier to find stuff. It's kind of like how people organize their closets or their garages or their desks or something. You're following an entity relationship and a dependency kind of thing, where you're going to put all of the lawn yard stuff in one pile, and you're going to put all of the kitchen stuff in one pile. Especially if you're moving, you really notice this when you start boxing stuff up. Usually people box stuff up by like kind, and then they have boxes, 1 of 2, 2 of 2, 3 of 2. So you keep it all organized, because one box is going to depend on another box, because half the parts are in this box and the other box has the other halves. This is really what you're doing with the database design. You're moving. You're boxing everything up and putting them into groups, and then you're establishing the connection between the groups, which is what dependencies and dependency diagramming is all about. So you have to make some assumptions, because this isn't the real world. This is, you're mimicking it in a diagram, and these assumptions should be listed clearly. So turn these relationships into dependencies, and here's some examples of single-valued and multi-valued dependencies, and this really gets you thinking about cardinality, multiplicity. So single value, so there's one and only one value of x for every value of y. So a person Y receives a grade X for a course in the semester. There's only one grade you get for your final course. Actually, in the past there's been multiple. one grade, and it doesn't change. One grade for each course. And a person Y has a birth date X, only one. So that's a single, it's called a single valued relationship, where person Y has one birth date or has one grade or has one. So it's a one-to-one single valued dependency. That's the best form, but we also have, I shouldn't say best form, the easiest form to work with. But then we also have the multi-valued dependencies, where we have 0 or 1 or more x's for every value of y. So student Y enrolls in 1 or more courses. That's a multi-valued dependency. And then a person Y has 0 or more sisters, or brothers or whatever. That would be a multi-dependency. So you then draw a dependency diagram. This is repeated in the assignment, in-class assignment notes as well for you, but this is lecture 2 if you're looking for the source of this information when you start working on that. And we're going to do problem number 1 together of that exercise, and then I'll have you work on problem number 2 and problem number 3. They're brainstorming exercises is what it's all about. And there's multiple different ways of drawing the dependencies. But let's take a look at the syntax, how it's put together. Here's a single valued one-to-one dependency. So we draw a single headed arrow for a single valued dependency. So if you're looking at the slide here, the red line, hopefully it shows up here, and I'm hovering my mouse over the single arrowhead that shows up. So a person has one or more, a person has one and only one birth date. So here's our birth date, and here's our person. Notice we don't have any boxes. This is not an entity relationship diagram. This is referred to as a dependency diagram. And it's called a dependency diagram. You're not going to find too many symbol sets for this. It's used actually in a couple different disciplines, but it's kind of a universal, it's more of a teaching diagramming approach than it is a in-practice one. Entity relationship is more the in-practice one. But this will help you build better entity relationship diagrams in the end. So here's a student that has one or only one final grade in a course. So you're putting in bubbles, and you're drawing lines between the bubbles, and you're showing dependencies. The lines don't have to be in red. This is for illustrative purposes. But there is only one arrowhead showing a single valued relationship versus 2. So now we have 2 double arrowheads, and you can draw them like lines, like double lines. You don't have to have arrowheads. But you'll see this with the data flow diagrams, actually, because one piece of data that's going to flow through, it's going to be processed through, is going to lead to another piece of data that's going to lead to another piece of data because there's a dependency on that. So this is the start of another diagramming technique called data flow diagramming as well. But we're not going to look at that one because we don't really need it for databases. But if you were studying software engineering, that would be part of the software engineering concept to just basically describe the data flow, which is not really the data, it's the processing of the system, which is kind of interesting. So here's the multi-valued one-to-many dependency. So you draw a double-headed arrow here between the multi-valued ones. So a student can enroll in 1 or more classes. So we have 2 arrows on here. So we have student with 1 or more classes. And a student has 0 or more sisters. So here's our person with our, double arrows here for sisters at the end. So we can see the difference is that the double multiple has multiple arrowheads on the end. So independent versus dependent attributes that are associated. So some of the attributes are dependent, some of them are independent. And so we say, well, there's no attributes in this diagram. And it's not like bubbles, or it's not like a list of attributes that show up next to it, because these aren't entities. These are just dependencies. So we talk about attributes, we're usually talking about pieces of data that are associated with what's going to turn into an entity when we start looking at entity relationship diagrams. But as an example, in a business, a client relationship. So a client's telephone number does not depend upon whether or not they have a schedule appointment with anybody. So you can still be a student, actually at this university, and not take any classes, but you're still a student. You still have student records even though you're not taking classes. Or maybe you are taking classes, so then you fall into different tables of information that might be stored about you. But regardless of what classes you're taking, you're still the same student. So that would be an attribute that's associated with you in terms of a independent relationship that you would have with the data. Your client still exists whether or not they have an appointment. So the appointment time would be a dependent thing. The telephone number would be an independent thing. So some attributes are dependent. As to the length of the side rails of a bridge is dependent on the structure of the bridge. So you can't have side rails for a bridge if you don't have a bridge. So you can't take classes unless you're a student. So to take classes, to end up in the class's data, you'd have to be a student, which makes it more of a dependency. So it would be a dependent versus an independent relationship that you're experiencing there. Side rails of the bridge would not exist. There was no bridge. So here's the difference here. So here we have, and you see that we have this phone number and we have this time that's not differentiated as an attribute, but it's a dependency. So everything, in a dependency diagram, everything is a dependency. It's actually easier. There's no differentiation between attributes and relationships. Although the lines are showing you the dependencies, but everything is a dependency. So here we have an appointment, and we have this dotted line here, and the line for the time arrow is connected to the dotted line, which means the time is dependent on the relationship, this relationship with the client, and we have multiple relationships with the client. But this relationship with the client is for the appointment. So this arrow here is connected to this one, where this here client is connected to this through the outside one, is connected to the phone number. So properties of the attributes are attached to the new bubble here, this one here, the dotted line bubble, that are dependent on the attributes of the attachment to the old bubble. So the old bubble and the new bubble is still a relationship. There's still a dependency with the client, but one of them is for an appointment and the other one is for the client in the database. So if this is you, if you were the client or the student, then you would have personal information that was attached to you regardless of whether or not you were enrolled in any classes. And then this might be a class or something that you were enrolled in terms of the concept. So each appointment is with 1 or more clients. So the appointments here we have double arrow to say we have an appointment with 1 or more clients. So we have the multiple dependencies being shown in here. And then each appointment is with 1 or more client has a time. There's an appointment that has a time. And then each client has a single phone number. So this is the appointment relationship, this is the client relationship. So you can this is what you'll be doing for the second exercise actually, is putting stuff together that looks like this. And it helps you to see dependencies, it's practice essentially, to see dependencies within the data. So you can see what's going on. So when you design the tables, you draw the dependency diagrams, and then each dependency statement is part of the diagram. And then each statement is a single path through the diagram. The tables are formed by traversing the dependency diagram until you run out. So you start at this technique, you start at the end and you reverse back, and everything you run into turns into a table. Lends itself to problems, which is why entity relationship diagramming is a little bit better, because we'll see that we'll be writing entity relationships tomorrow. But there's something to be learned by examining dependencies, because then you'll be able to spot them a little bit easier, especially when you see dependencies within the same table, and then you go, well, that's wrong, because one piece of data is dependent on another piece of data. Well, if you're not familiar with it, or you're not open to seeing the dependency, then it's hard to actually identify it, to actually troubleshoot problems. So it's just a way of thinking. So in terms of traversing the dependency diagram, choose the attributes at the end of the path, and then follow the path all the way back up to the beginning, which is a slightly different way of translating this into table structure, because this can be translated into a table structure. If we did that, we would have one table, two tables, because we only have two paths that go back up to the beginning. If we were to create this as an entity relationship diagram, we're going to have 1, 2, 3, 4, 5 tables, which gives entity relationship is going to give us a third normal form database. This, if we translate, is going to give us a first or a second normal form database. So it doesn't lend itself well to database translation, which is why we're going to use the entity relationship for that. But this tells us something that entity relationship doesn't show us. This shows us the specific dependencies among the data. This helps us with the keys, actually, because we know we have to keep track of, and there's somebody talking in the back. Another person stopped, which is good. We know we have to keep track of the keys that are going to tie the dependencies together, because one piece of data does depend on the other. And this diagramming technique trains you on how to create better entity relationship diagrams as well. After you verify the design, you inspect all of your tables, and you see if all of the data is included. Do you have too many tables, too few tables, and if the design doesn't appear correct, then you go back to step number 1 and you see what's going on with that. So common database design mistakes, and these are design kind of mistakes that occur before we take a look at some of the examples. Assuming that the order of the rows of the columns is known, yeah, it's not a spreadsheet. Guessing the design and not following the process. Actually, you can see this because I can tell when someone has created tables by flipping a coin or deciding, oh, we need this table, we need that table, we need this table. And then they go backwards and they create the diagrams to match the tables, which is the backwards way of doing it, because their boss said, oh, we need diagrams too. Oh, okay. But they don't use the diagrams to create the tables. The big red flag on that is generally there's too many tables because they have duplicate data, because they haven't looked at the dependencies, and they haven't organized it correctly. And when you start creating the diagram, then you go, oh, and then you can fix the table after you create the diagram, which is kind of working backwards. It's kind of like re-engineering, reproducing the table, which is kind of interesting. So if you work the opposite way, take the diagram first and then use that diagram to create the tables, better, right off the start, better design. So that's what we'll be doing tomorrow, actually, in the class. Okay, so guessing, representing multi-value dependencies as fixed-size sets. That's also another common problem people do. So if you know that there's exactly X number of something, create X single-valued dependencies, otherwise use a multiple-value dependency. If you have a multiple-value dependency, anytime you see these double arrows, it's a trick so you know that this is going to be a separate table because you can't put two arrows in the same table if you translate it. So, well, we haven't looked at translation yet, so that probably doesn't not going to be meaning that much to you. Also, another thing is adding a key when a unique value already exists, or using a unique key instead of a primary key, and that may also be a problem. So adding an ID number for a person when there's already a social security number in the system could be a problem. So if you follow the process correctly, you will not have any redundant data. You will also not lose unrelated data, because here's what happens. You take all this data, you separate it out, you put it into different boxes, and lo and behold, every time you move, this happens, the same thing happens. Where'd that box go? I'm missing one of the boxes, and you can't find it. But later on, you do find it. Actually, sometimes you don't, because sometimes it gets thrown in the garbage or the Goodwill pile, the donation pile, and you're like, where did that box go? Oh, it got donated, because the box ended up in the wrong pile or something. So can the data. It can end up in the wrong category, the wrong data, and then it's not linked, and there's no way of getting to the data. After you've separated it all out, put it into different boxes, then you can't find it, which is a common problem with databases as well, which is why people are hesitant actually in the beginning to put a database together, because they think they're going to lose the data. There is a likelihood, if you don't design it correctly, that you will lose some data from that. So Databases with all of these characteristics will be in third normal form. Normalization will be discussed later in the course. So, and here's the goal for the business applications, because what you're doing is you're all building business applications when you deal with a database, because a database is the foundation. There's no such thing as a database application. There's a business application. It works with a back-end database. That's what you're building, the database, or you're building the application to work with the database. So the database design, the queries, and the programming are the three kind of tools or components that are going into this. In a worst case scenario, if you think about the concept, there's only one database. There's only one SQL language, but there's multiple programs that access the same database. So in a worst case scenario, compensate for the poor design with limited SQL and a lot of programming. So that's why this programming thing is really high, because this is going to be a lot more work. It's going to cost you a lot more time for each new program that has to be written. If you spend more time on the database, then you can compensate with more SQL, and then the programs are easier, because the database is practically self-contained, and the database just works, and the applications just connect to it and read the data. And so the database is basically the powerful tool, the component that's making everything work. And then you can have millions of programs, and the programs don't take you as much time to create. So unfortunately, where you guys are, your exposure will be to this right here, because they're hiring you as contract or as interns or something on all of your SQL, because there's a problem and they just need to throw bodies on it sometimes to fix the problems. And then you're dealing with this when there's a lot of work for a program that really shouldn't be that hard, because the database design is not wasn't done correctly. So this creates a lot of jobs. This is not so good for job security. Because if it's easier, then they don't need to hire anybody. So pros and cons, database design. And looking at the application process, this is a waterfall model. If you're not familiar with software engineering, and software engineering of databases falls into this category. We have feasibility in the beginning, which is what someone's going to give you a problem description. We're going to see a couple of them in a few minutes when we start looking at the assignment. So you take the problem description, you're identifying the scope, the cost, the schedule. For you, you're designing the database. So you're going to gather the information from the users in terms of your analysis. But there are no users, so you're designing it for yourself. The design enables you to define the tables, the relationships, the forms, the reports. And then you do your development to create the forms, the reports, the help system, the testing process, and then you implement it. And in the implementation of databases, it's actually kind of easy. You're transferring data into it. You're importing data from spreadsheets, from files and stuff. Or you're taking a database that already exists and you're exporting the data and then importing it, perhaps back into another data. Then you train and you review and you start over again with a new project. This is just the typical process that most developers go through in terms of the analysis. In terms of the features and components, we have the database engine. Actually, this is kind of interesting. Everything on the left here is standard for all databases. Everything on the right is what you pay extra for. So Oracle is an example, and MySQL, everybody's going to have a database engine. If you can't store, retrieve, and update data, there's no sense in having a database. That's basic concepts. But who's going to have a report writer? Oracle doesn't have a report writer, not mixed in, especially not for free. So we have Oracle Reports, Oracle Designer, Oracle this, or all separate packages that you buy. Not cheap either. And then you go to separate training programs for each one of those packages, which is kind of interesting. And when you go to the Oracle training, that's what they're training you on, how to actually use their software, because their software is not very intuitive. So they have to actually provide you a training on how to use their software, which is ridiculous, actually. Well, the more complicated they make the software, the more they can charge for training, because the more people will actually go to the training. It's big business, actually. So, application generators, communications, programming interfaces. Those are kind of the add-on products. Over here on the definitely included list, the query processors, the data dictionary, utility, security, stuff like that. And here's a graphical picture of this slide here. So we can kind of sort of see the database tables. This is the bare bone design of part of the engine itself. Security, utilities, these are all add-on products and features and things that you're going to get on the database. So it's not too bad. I just thought I'd show you Microsoft Access so you can kind of see what I was talking about before. If you haven't seen Microsoft Access before, if you're a Mac user, you've never seen it. It's not included on Mac Microsoft Office. If you're a Windows person, you probably have seen it. In fact, most people used to install it by default, never use it. Now you can actually, it's not installed by default. I think you actually have to select it now to install it, which is how popular it is. It's limited. A lot of web developers like to use Access because you load the one file, you put it on the web server, and it's easy. You just open the file and you put it into a data store, and you work with it. It's easy. And a client-server database, which was one of the questions on your first exercise, you're connecting from anywhere from a client website. You're connecting to the server. And when you sign up for an ISP account, you're going to get server access. You get a login name, you get a login password. You go in, you build the tables and stuff out there. And so there's nothing to store locally. You basically just connect to the database, run the functionality, populate your HTML screen with all this information that comes back. So it's a slightly different fashion. Here's what the Oracle, this is an old screenshot, I want to say of number 7, Oracle 7 or so. We're up to 11G now, so definitely looks different than this, which is like a spreadsheet. This one is more of a hierarchical design. The schema manager is still there. Schema manager is going to be able to have you graphically configure everything in a hierarchy for all of the components that you're looking at. The database reports, this is a Microsoft Access report, showing you kind of a primitive report layout over here, versus the Oracle report generator. I don't believe this is this current one that they're shipping. I don't believe they're shipping anything anymore, and you'll never see this with the Express version. So you might be wondering, well, how in the world can we get Oracle Express for free? Well, you don't actually get the whole Oracle. You're not getting reports, you're not getting designer, forms generators. All you're getting is the engine. And the engine's only going to allow one person at a time to log into it. And it's going to take up a lot of memory on your computer. So back in the day when we used to actually install Oracle Express on your computers, generally there's a performance hit. So you can't leave it installed. You'll have to uninstall it eventually, which is not such a good idea. In fact, I wouldn't run out and install Oracle Express unless you want your computer to run like a snail for the next couple months. You don't really need it either, because what you're getting is a query processor, a query engine, SQL window. I'm going to try and get a Windows 7 machine so I can install it. And you can buy Windows 7 computers for like $200 right now, but I'm hoping someone's. Well, I have a couple people who said they were going to loan me a system, because probably this weekend, hopefully sometime, I'm going to run through the install of Oracle. But I have to secure the system first. I'm hoping to get it for tomorrow, but we'll see. Because it wouldn't be a bad idea to actually install it, because when we start writing queries, for designing the tables, no problem. When you start running the queries, it's nice to see the queries work. So it's nice to be able to run the queries. So I either have to download 10G, or I've got to find a computer that has 7 on it. I'm not installing 7 on this MacBook, so I won't go that far. So we'll see what happens. No guarantees. Either that, or I can access MySQL and run the same queries on MySQL on a PHP admin or something. I just need something to run queries with. So actually, I could probably do it with Microsoft Access, but that will happen late tomorrow or Sunday. Is when we're going to start looking at that. So, database input. So we know reports are going to be the output, or the forms, not the forms, excuse me, the reports, the HTML output, or whatever it is we're going to use it for. Inputs in the form of forms. So when we talk about input, getting stuff in, we create forms that are going to appear. So. And then we have the components here. This is just yet another view of the big picture, where we have the network connection, query processors, third generation connectors. This would be your JDBC drivers and all of your other things that might connect to a program, or might connect to a form builder, a report writer, or application generator. So all these kind of components work together in terms of the system. So. And just to show you briefly the differences between an object-oriented database and a relational database. As I mentioned earlier, the relational database is in the form of tables, where we have a customer table here with a name and an ID, order, items. And then we have the object-oriented version of it, where instead of calling them tables, we're calling them objects now. They sort of look like entities, actually, but they're really objects because there's 3 parts to it. There's the name of the object, in this case order. There's the attributes that are associated with it, and then the methods The methods are the functionality. So here, a new order, a delete an order as examples of some of the functionality. And then the order ID, customer ID, which would be columns or attributes. So attributes turn into columns in the database table. The order is the name of the object itself, which turns into the, not a table, but an object name. So in a relational model, we create these tables. And we use a create table, blah, 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 in SQL, or we drag and drop and create the tables. And here we create the objects. When we create the objects, then we have to define the behaviors between the objects. And it's more programming. It's more object-oriented programming fashion. So if you're interested in using a database like a programming language, then you go the object-oriented route. Because then you're designing a program that has database objects inside of it. And the objects are representing components. And the objects themselves are communicating back and forth and performing the functionality for you. Much different way of thinking than the relational model. And not everything works with it. So it's easier to make an application that works with that, because you just, connect to the database object, open up this table, read and write or query a table, and you're using SQL. This one you're not using SQL, and well, you could be, but you're not always using it. Don't have a table. You have to make a new instance of an object. But how is your web browser going to make a new instance of an object on the database? Why are they going to do that way? And are they going to run it that way? Which is kind of interesting. It's a lot easier to conceptualize that in terms of the design of third-party applications. And here's our object concept here with the object definition, the object name, the properties, the methods. And then we have inheritance for objects that we can also keep in mind, combining into one table. If we had an inherited object that removes the possibility or the complexity of joins, so in order to create tables that work together in a relational model, we have to use joins. We take this table and we join it with this table. And this is the old-fashioned way of doing it. If you think about the benefits of an object-oriented database concept, we can inherit one table from another table. And then we join. It's kind of like a join if you think about it in terms of the concept. But it's also an inherited concept as well. So you're not reinventing the wheel. You're using the existing data, and the existing data is stored in this object. You're inheriting from it, and you're creating new data in this object. Way different way of thinking about databases and database design. So you can't create an entity relationship diagram that works with inheritance. It doesn't work. So they haven't actually, there's no such thing as a object-oriented database design methodology yet. Well, one that's well known or well established, or that's become a standard. There's a lot of theory right now, but there isn't really any standard that's been developed yet. So databases that work with an object-oriented concept have difficulties. It's difficult to design it from the beginning. So you definitely have some issues with that. So, however, if you can get past the design, what we're looking at is multiple tables with a link by a primary key. More efficient. You need to add rows to many different tables, and you basically use it the same way as before, but it's inherited. So here's an objects in a relational database that are put together, so we're separating out the inherited classes, linking them by a primary key. Adding a new customer requires a new row in each one of the tables. Here you don't actually have to put a new row in each one of the tables. You're making new instances of objects, and you're inheriting from previous objects all of the behavior, so there's no new row. So you might think one of the selling points for object-oriented databases is a lack of duplicated data and fewer numbers of rows that are being stored. Relational databases, there's a row in this table for a row in that table for a row in that table. Lots of data. But hard drives are big, databases are big, plenty of room to store stuff. But we have issues querying it. It takes longer to query a table that's huge than one that's small. So there's pros and cons to it. And the research right now is showing that object orientation might be a viable option in the future. Object-oriented difficulties in here. We have the difficulties with methods as an example. So out here we have a Linux server, and if you're still having problems with the client-server environment, this is a client-server environment. So we have a Unix server that's housing a database object. And we have a method here that says add a new customer with some program code. And then we have a database object over here on an IBM server. And then we have a personal computer over here, maybe a client who's connecting to these database objects. And in the client might have a name, address, a phone number. So how can a method run on different computers? Well, that's an interesting problem. Java sort of solved that with RMI. So we have remote method invocation that can happen. In fact, if you take the Java EE course that's offered here, one of the things that's demonstrated is the concept of the RMI, and you'll be able to work with that to kind of see how that works. But it's a nice answer. So Java made it possible. And so as soon as Java came around to make object orientation work with those remote procedure calls, all of a sudden a lot of research started going in that direction. And so object orientation now becomes a viable option in terms of database design. So let's look at in-class exercise number 2. Okay, this is the last activity for today. And it's kind of scary when you look at it because it's about 4 or 5 pages long. Not so bad though. In fact, I just realized it's labeled number 3. It's really number 2. I have to change the labeling. But see, the objective of this first assignment, not really even a first assignment either, I have to change the wording, is designed to help you get some experience and practice creating dependency diagrams. So, your task, draw the following 3 dependency diagrams. So the first thing you're going to draw, how am I going to draw? Here's your options. I didn't get any paper. I think I was supposed to get some paper, but if we want paper, I can probably go find paper. If you draw them in class, you'll have to take them home and scan them in. So that's option number 1. Option number 2 is to use Paint. And I'm going to take option number 2, because this is easier for me to show you. So I'm actually just going to take the same document I had before and clean off my plate here. Hello. Okay, cut. There we go. Get rid of what's on there. And I'm going to do number 1 for you, actually. So we have 3 questions. We have 1, 2, 3. I'm actually going to do number 1 for you. So if you pull out Paint, you can do number 1 too. Or if you pull out a piece of paper and a pen, you may do number 1 as well. And we'll have half the work done for you already. So I'll give you a few minutes to pull out your paper and your pen. Now if you're doing it on paper, you're going to have a way of scanning it in. The due date on the assignment is Tuesday. So you don't have to scan it in this weekend, you can wait till you get back home. And Tuesday during the day, you can scan it in at your work or wherever you are, and then upload it into the EMS. Kind of like one of the reasons why I set the deadline for Tuesday. Because, this stuff that you're going to be doing tomorrow, you may also want to do the same way, by hand. So. Okay, I need this volume to come back down again so I can talk. Or I can just shut up. Wait till everybody stops talking. Shut up! Be quiet! Hello! Shall we take 5 minutes? Okay, I'm back. Oh, so are you. Good. Alright, so I'm going to flip to page 2 here. Now that we all have paper out, hopefully. If we don't have paper out, borrow from your friends. Or if you have a computer in front of you, open up Paint. Okay. So page number 2 has the how to do this instructions on it. This is a repeat. This is a repeat of the lecture. Comes out of that lecture I just gave you. So we can see the single valued relationship here. These are the same diagrams and the multi-valued relationships here. And the dependency here. And this is what tools you want to use. Well, you can use a pen, a piece of paper. You can use Smart Draw. You can use Paint. Don't use anything too sophisticated for this, because what you're going to see in a few minutes, it's actually not so bad. Okay. So question number 1. And this is for everyone who gets, what did they call that? You know, mind block? Roadblock? Or something? You know, like when you look at a question, oh, I don't know where to start with this. That's why we're doing number 1. Mind blocked or something. You know, actually usually happens when you look at a blank piece of paper. You sit there, okay, write something. I don't know what to write. I'm looking at a blank piece of paper. How do I start? All right, number 1. Draw a dependency diagram for the following situation. Doctors prescribe drugs for patients. A given doctor can prescribe many drugs for certain patients. And many drugs can treat a patient. Okay, good. Many doctors can prescribe the same drug to the same patient. Then this is when the mind block sets in. What do I do? All right, so step number 1, if I were doing this for you, which I am right now, and you're going to watch me do it, I'm going to identify the dependencies. So you're writing a dependency diagram. We are not writing an entity relationship diagram. However, I'm going to turn this into an entity relationship diagram that you don't have to do. But I want to show you both to kind of give you an example so you don't have to do one today, but you'll be doing it tomorrow. Okay. So I have doctors and I have patients, which are sort of like nouns. So I'm going to have those. So I'm just going to take out this little round guy here. I'm going to go doctors, and I'm going to go patients. So I'm going to take here, I'm going to call one of these guys doctors. I'm going to make this a little bit smaller so you can sort of see this. Doctors. And I'll put here patients. That looks pretty good. Then I'll cut these guys out. I'll stick them in here, doctors, patients. And what I like about paint is you can just like move stuff around, which is nice. So the first sentence here, and take it sentence by sentence, doctors prescribe drugs for patients. And it looks like drugs. So now I'm like, well, where are the drugs? Uh-oh. Well, then I can go, well, if drugs, I think it's going to be drugs, right? So they're going to prescribe drugs. And what I'm doing is going through a brainstorming exercise, which means my first impressions may not be correct. We're going to build this iteratively through a brainstorming process, which is going to show you how you're going to think through the process of solving these for the next ones. So I have drugs. So I'm going to come out here and I'm going to put, okay, now I know about drugs. So I'm going to put drugs in here. Oops, that's why I don't like to put it inside. Let's see, I didn't undo. I'll put it out here, drugs. Oops, drugs. Alright, so I've got doctors, patients, and drugs. Now they're going to prescribe, and now I've already known a little bit about entity relationship diagramming because I gave that to you first. So if I were writing an entity relationship diagram, and you can do a hybrid, because you want to think about entity relationships, this would easily turn into an entity relationship diagram of 3, which is why I'm putting it like this, with 3 degrees to it, because I have doctors that prescribe drugs with patients. So I have multiple dependencies here. They are dependencies. I'm not going to torture you with drawing the diagram. However, if you were to draw a diagram, you'd put a diamond in here and connect it. Or I could take and say, well, let's see, what do I really have? Doctors that prescribe drugs. So I could go here, and let's get rid of this here for a second. Oops, cut, to cut it out here. That's one way of thinking about it. Or I could do this and say, well, okay, so we have doctors that prescribe drugs. So can't we just go up here like this and go doctors prescribe drugs, and then put a little arrow here. Maybe it's drugs plural, so I got 2 arrowheads here. And then I can take and I write the word prescribes on here. Whoops. And I'm thinking 2 relationship. I'm thinking about doctors prescribing drugs, but who are they describing them for? Patients. So I could do this as well. I could come down here and say, well, patients. All right, so patients. But am I really, drugs are for patients, and doctors are prescribing them. And this is one of the problems, the reason why I'm going through this. This is one of the problems with dependency diagrams. We have the dependencies because we know that doctors are prescribing the drugs. So there's a relationship between the doctors and the drugs. And we know that there's drugs that are prescribed for patients, and the patients are the people using the drugs. But it's harder to see the real relationship past the dependencies. So at this point, you're kind of wondering, you should be wondering, well, then how do we know if this is correct or if the other one is correct? Well, for a dependency diagram, this is actually more correct because you're showing not the relationships, you're showing the dependencies. So if I read through a little bit further, I might need the second sentence in order to get the first sentence correct. So the first sentence here says, doctors prescribe drugs for patients. So prescribing could be the verb of the sentence here. And the doctors are prescribing drugs for patients. So here, I could just do this here if I wanted to and put here for patients. That's one way of drawing it. Maybe not the best way of drawing it, but it is showing the dependencies correctly, which gives you more than one right answer, actually, because I'm going to make this a little bit bigger here. The other choice that we could look at is to draw it this way and go, doctors are prescribing. You know, actually, I'm going to leave this one up here. I'm going to draw another one underneath it. Doctors are prescribing. Oops. And don't worry about it if your diagrams look like a kindergartner wrote it, because it's going to. The other way of doing it, we go here and go doctors. What else do we have here? Drugs. Patients. And here's another problem with the dependency diagrams, which is why we're not using them. Doctors, drugs, patients. Then we have this to take in consideration. Well, no, actually it wouldn't go this way. What did it undo? Which is really the same thing, but then we can connect, and I should have driven it this way, but I'm doing it separately just to show you the two variations, just in case you miss it. Because we might think that doctors are treating patients further down the road. So if we take the blinded view of just reading the first sentence, we can miss multiple relationships that are going on and multiple dependencies, because this first one is wide open. So I'm going to move past the first one, and I'm going to go to the second sentence. So, a given doctor can prescribe many drugs for a certain patient. So that's telling us about the cardinality. So we have, if I'm working with, and I'm going to work with the lower diagram right now, actually, because many doctors can treat a patient. And if I've gotten to the many doctors can treat a patient, then I'm really looking more along the lines of this three connections going together. Yeah, so this is, let me just do this another way here as well. These are dependency diagrams that I'm drawing right now. I'm going to also draw an entity relationship diagram so you can sort of see the differences. Oops, I'm trying to make this bigger. There is a way of making this bigger, isn't there? Oh. Hello. Ah, there it is. Okay, so if we were to draw this as an entity relationship diagram, we would use entity boxes or rectangles. You don't have to do this for this first exercise, but if you were to do an entity relationship, this is what we're going to be doing tomorrow. Oops. So we got here doctors. Actually, it just could be doctor. Drugs. Patients. This is why this here, which is an entity relationship diagram, is more popular. This is clear looking to most people. Then the dependency. This is showing the relationships. When we start looking at the dependencies over here, we're going, wow, dependency, relationship, isn't it all the same? But watch this. We're going to look at, this is why dependencies are still being used, is because now we can go show multiplicity in terms of multiple valued relationships that we sort of miss. Makes it a little bit easier than this over here. It's just a different style. So now, okay, so we're going to, doctors prescribe drugs for patients. Drugs is sort of plural in terms of its sounding, so we have multiple arrows over here. Doctors that are prescribing drugs, multiple drugs. So I'm going to write 2 arrows over here as well. So now I have doctors prescribing drugs. And you only have to write 1 diagram, by the way. You don't have to do all the different variations. A given doctor can prescribe many drugs for a certain patient. So a given doctor can prescribe many drugs for a certain patient. Well, that's already in the diagram. So here now, this is one of the problems right now, is you're going to have a situation in which it's a duplicate sentence. What does that mean? Well, maybe it means something in the next sentence. So the next sentence says many doctors can treat a patient. Has nothing to do with drugs, which means we need this connection. Drugs, patients, doctors, patients. So we're going to need this here. So many doctors can treat a given patient. So now I have doctors that are treating patients. And I could put the word treats here. You don't have to put the words, like I put prescribes up here. You don't have to put those words. This is a proper dependency diagram without any words. The words come into place when we start looking at entity relationships. They added the words. So. And then I have here many doctors can treat a patient. Many doctors can prescribe the same drug to the same patient. Many doctors can prescribe the same drug to the same patient. So now I got many doctors. So I give many for multiples. So this right here is the final product of that one. Yes? Oh, to the same patient. Oh, I could put it on here. You're right. Actually, I left out the multiple drugs to the same patient, but we also have multiple doctors. So you're right. You're right, actually. To multiple drugs to the same patient. Hold on 1 second. Undo. Multiple drugs. Is that sentence I left out? And then I never got back to. Many doctors can prescribe this many drugs. A given doctor can prescribe many drugs to a certain patient. Many doctors can treat a patient. Many doctors can prescribe the same drug to the same patient. Same patient, drugs. Doctors can prescribe have many patients. Doctors can prescribe many drugs to the same patient. Many doctors can treat a patient. Ah, many doctors can treat a patient. There we go. Many doctors can treat a patient. What we're doing is we're putting in the business rules by showing the multiple dependencies that exist. I'm not going to nitpick your diagrams. It's a brainstorming exercise to get you to think about how to put this out on paper, and it's a thinking exercise, which is what we've been going through. So you might have drawn it like this, and if you had done that, you could have put another line. Oops, another line in here. You could also draw this out as 2 separates. If you had put the line in here, you could have filled it in, or you could have done this, actually. Let me make this bigger. Ah, there we go. I'm going to move my entity relationship diagram down here. And I'm going to stick up here this concept. Many doctors and many doctors and many patients. Not putting all 3 of them together, but putting them separately. Doctors and patients, drugs and doctors, or drugs and doctors, you know, and I would believe there would be a treats as well, maybe doctors treating patients.
I think over there in doctors and
Mm-hmm.
patients, the lower one. Yeah, lower line.
This is gone? Oh, right here? Needs to be this way too?
No, not there.
Oh.
I was just wondering that there should not be multiple arrows between doctors and patients with the patient.
Oh, you're right. Because many doctors can treat many patients, but many patients can get drugs from many doctors, but not. Oh, you're right. So we would take this out then. So I told you I wasn't going to do it correctly. So we would technically, if there's no arrow, here's another tidbit to tell you. If there's no arrow at all, if there's empty, it's usually assumed to be 1. If there's more, then you put 2 in. So here, this is assumed to be an arrow, but there's no arrow. If I wanted to make it multiple, then I'd put 2 arrows in. If I were to create this as an entity relationship diagram, it would look like this guy here. And this guy here is missing its cardinality. So in here, I would probably put treats. So this would be treats. Not like trick or treat, but treat, like cares for treats. And it would be inside of a diamond symbol. And then I would have to worry about this stuff. So I can say, I don't remember the rules, but it's many doctors, right, that can treat a single patient. So then I would go 1 doctor or 0 or star, colon star. Or I could use this syntax here, 1 colon 1. Or I could use what was in the slide set, ... So these are different ways of showing the multiplicity and the participation, by the way. And we'll review this tomorrow when we start drawing the entity relationship diagrams. But here's what I do, which is not quite the best way of doing it, but it is a valid syntax, is I'll put the symbol in here. Whoops, let me create it first. Actually, here, I'll just cut one of these asterisks here. And I'll do this. Maybe I should have copied that. Copy, edit, paste. Well, actually, the patients is only a single. So this would be a 1. So if I clean this up a little bit, actually I can clean this up a little bit here too. I'll just leave this alone. Okay, hold on 1 second. There we go. So this is supposed to be a single, I'm going to answer your question in a second, but this is supposed to be a single kind of marking, which is actually kind of a valid way of doing it. If we were to translate this into an entity relationship diagram, this is showing participation in, actually it's not showing participation. It could show participation in multiplicity as well as the relationships. This is just showing dependencies. And so the problem is determining what is the dependency, which is the challenge with the dependency diagram. So some actually think that writing the dependency diagrams are more complicated, and I'm one of them. I think it's more complicated than this, but this is easier to change if you have a question, and this is more flexible. This is rigid. This is flexible. This is a bunch of circles with a bunch of lines connected to each other, and we're not really worried about relationships. We're only worried about dependencies. So there's no such thing as drawing multiple lines, because you don't have multiple relationships, you just have a dependency, one dependency, whatever it happens to be. Okay, what is your question? This one? This is an entity relationship. Yeah, this one. Okay.
What's the diagram?
This is a dependency diagram.
Dependency diagram, which the drugs is going towards the doctor. Arrow, why there are 2 arrows towards the doctor? Drugs going towards the...
Because many doctors can prescribe many drugs.
Yeah, then the arrow is towards the drugs. I can understand that.
Mm-hmm.
But why the arrow are going towards the doctor?
The doctor arrow from here? Drugs to doctors? Oh,
Yes.
There's no direction. Ah. It's a very good point she's just made. She's wondering why the arrowhead is going in the direction of the doctor. It's not a directional arrow, it's a dependency arrow. It's not showing that the drugs are going into the doctor. So this can't really be read left to right, right to left, like this can.
No, I can understand the doctor can prescribe many drugs.
Mm-hmm. Well, there's many doctors that can prescribe many drugs,
Yes,
I believe, yeah.
So that sentence, the arrow is going towards the drugs, yes? Saying the doctor can prescribe many drugs.
But it's many doctors. So that's where the arrows here are coming into place. It's not that the drugs are flowing into the doctor, or that the doctors, it's really the doctors that are prescribing the drugs. The drugs don't prescribe doctors, but many doctors prescribe many drugs. Which is not, that's the other problem with, this is just showing dependencies. It's not showing direction.
So many doctors means the two arrows there, and many drugs means.
Yep. If you don't like arrows, let me show you something else. Yeah?
By symbol, like asterisk and 1 is to asterisk or 1 by 1. Kind of like we can draw a symbol.
Yeah. Watch this. Watch this. If you don't like the arrows, a common dependency, and you'll see this more often in the literature because, okay, she just brought up a good point. The arrows have a tendency to figure direction. I don't know if that was your point, but that's my point. Has a tendency to say, how do the drugs affecting the doctors? Well, maybe the doctors are taking the drugs, who knows. But if you don't like this kind of syntax, there's another one that you might like better. And I'm going to erase this for a second and show you something interesting. Because you'll see this in entity relationship diagramming as well. And you might want to practice this one because this will help you get familiar with more entity relationship concepts. So you draw the line between the two. And then you put lines this way. This would be 1 to 1. This is many to many. No arrows.
We can use M as a
If you're going to do that, you may also, not standard. This is standard. Not as standard, but I'll take it. You can go like this. M or asterisk. Or N. N would mean that there's a certain number, like on the airplane. But there's a fixed amount of, well, is there really a fixed amount of drugs? Many drugs. With many doctors. Or you can use the asterisk as well. And then you don't have to put anything on the line. And many to many. Yeah, that would be many to many. If that were the case, I've also seen it this way, but it's not standard as well, is to put this in the middle, is to go like this. Not so standard though. So when I say not so standard is if you draw this out in the real world, they're going to look at you like, what in the world are you drawing? Like, where did you come up with this syntax? It doesn't exist anywhere. Oops. Well, anyway, I'm just going to settle down. We're almost ready. Is to get rid of all this stuff here. And put this on the line. And then what you're looking at is a dependency with many to many that's going on here. That is also acceptable. Not standard though. The line, these are more standard actually.
And here it says that the patient can go to many doctors.
Uh-huh.
That's why 2 arrows.
Yeah.
But a doctor can see a patient, so it should have 1 arrow at least.
Well, let's see. Is it talking about a doctor that can prescribe drugs for patients? Settle down. It's a little too loud. A given doctor can prescribe many drugs for certain patients. Many doctors can treat a patient. Patient, yeah.
1 arrow should be there.
You can put it 1 arrow or you can leave it blank.
Right or wrong?
Yeah.
I'm just asking.
This one here can be left blank. Shh, settle down. Or you can put 1 line here. Or you can put an arrow here. One
Yes,
single
but
arrow.
Is it right or wrong that there should be a 1 arrow from doctor towards a patient because doctor has to see just 1 patient, then only he can prescribe his drugs. So there should be 1
But it's
arrow.
many doctors with 1 patient.
Yeah, if many doctors with 1 patient, then there should be at least 1 arrow. I'm telling you, like there should be an arrow there. If there is no arrow before, that's what I'm asking. Like,
Oh, you can put an arrow here if you want, or you can leave it blank.
No, according to the question, should there be an arrow or not?
It doesn't matter. If you put the arrow there, it's the same syntax. If you put the you can put an arrow there, you can put a line there, or you can leave it blank. It's all saying 1.
Here we said patient is 1.
Patient's 1.
1.
This is 1. This is many.
Because I can understand, but before diagram, you didn't put any arrow towards the patient.
I know, you can leave it like this, or you can take the arrow out, or you can take the line out.
Then if you take out line, it
Looks like that. That's correct. There's many different ways of doing it. If you don't put 2 arrows there, it's single. Yeah, it's the same meaning. By default, if you don't put anything on there, it's single. Yeah. People don't like arrows, people don't like lines, they don't like numbers, they don't like characters. Let me show you something else to confuse you even more. We have crow's feet. So when you download, and we'll see this tomorrow, we'll see more of this tomorrow when we look at entity relationship diagrams. We've got some symbol sets that use, and here I'll make some room up here on the, I'm running out of real estate. I'll make some room here. That have 2 entities, and I'm going to draw 2 entities here, 1 entity, 2 entities. And I'm going to take and do what's called crow's feet, which I seriously don't like. Crow's feet symbol goes like this. If we wanted to do a full crow's feet, we put 1 line here to say 1, or we leave it blank, and then we go this way. Opposite arrows. Some people put 3 of them in. They call them crow's feet because they're like the feet of a crow, of a bird, and the bird crow's feet comes in and attaches to the... I hate that. I think this looks sloppy. In fact, I can't write it correctly, but here, I'll put some crow's feet here, write it better. Oops. See, the crow's feet is hard to put in here. Here we go. There's got some crow's feet. I don't like that. I'm a line person. I don't even like the arrows. I'm a single or a double line person. That's what I do. And in fact, I don't like all the 1 to 1, 2 to 2, 2 to 3. I'll just put a single asterisk here or 1 here. So we'll see tomorrow when we start writing entity relationship diagrams. There's many different ways of doing it. So, okay, so yeah.
What is that line about? If there's no arrow, it means default 1.
Yeah. That's where you. That's what your question was. I remembered. So. Okay, so let me forewarn you about question number 2 and question number 3, because in a few minutes you're going to start doing these yourself. This is why sometimes it's better to do it on paper, but then you use up a lot of paper. So sometimes it's better to do it like we just did it in there, because you can cut and paste and move things around. So it's your choice, what you find better. Number 2 and number 3 are almost impossible to build. Number 1 was pretty straightforward, I thought. Well, not really. Number 3 is vague. Number 1 is vague too. Okay, so number 2, let me just read you number 2, and I'm going to tell you what's wrong with this, and so you can kind of see where the thinking would have to come into place. Make an attempt to draw the diagrams. There's no right or wrong answer, because both of these 2 problems have problems in themselves. So number 2 says, draw a dependency diagram for the following situation describing a database for manufacturing parts, for a manufacturing part company. So, a company manufactures automobile parts. That's easy. You can go company, parts, and you know there's a dependency between those 2. Okay, good. There's 2 kinds of parts. So parts might branch out into primitive parts and composite parts. So parts goes to primitive parts and composite parts, maybe 2 separate angles there. Primitive parts are parts that are made up of other parts. Okay, they are invisible. Okay. Examples of primitive parts are spokes, nuts, bolts. Don't create a separate component for each one of those things. Those are all primitive parts. You could, but you don't actually have to. So this is where the confusing part comes into place. Is it a dependency or is it a type of part? These are types of parts. So you may not necessarily have to create a symbol for each one of those parts. They're all parts. So nuts, bolts, spokes, screws. Composite parts are those that are made up of other parts. Example composite parts are engines that contain several parts such as pistons, cylinders, rods, links, cranks, assembled into one big unit. Okay. Notice that the piston itself could be a composite part and so on. Each part has a name, a unique ID assigned by the company, and primitive parts have a cost, while composite parts have textual assembly instructions. So what you're going to do when you do this, I'm going to take this prescribing drugs kind of thing. Here's what you're going to do. Take a little box, and in the box, you're going to put in here, let's say if I was talking about drugs. No, let's do parts, actually. We're going to have nuts, bolts, screws, screws, parts. Put it in the box, or the circle, however you want to do it, and attach it this way, with nothing. No arrows, no lines, nothing. These would be called attributes that are associated with this. If this was, change this around a little here, let's call these guys parts, or composite parts, or something. I'm going to put it just here, parts. This is not really part of the diagram, but it's kind of, you know, examples of parts. If you make, you put all these as separate little dependencies, you're going to end up confusing yourself. So you're allowed to group them together as attributes, put them inside if you want to. You may also do this. Not very standard, but more standard when it comes to entity relationships, but not very standard when it comes to dependency diagrams, is to do this, where we've got parts. There we go. And then this is in replace of the circle over here, which is leading to sort of an entity relationship syntax. But this is a little easier to put together than all the little bubbles and all that stuff. So you can group them all together, because these are all types of parts, or maybe they're composite parts or something. So what we have then is trying to know what a part is, and what a composite part from a regular part, and the dependencies and the relationships that are associated with the parts. This third one is not so bad. And when I say these are challenging, they're not straightforward. And what I'm going to do tomorrow morning for you is show you the solution to this, which is why you're going to spend some time tonight before you leave in doing it yourself. Because when you see the solution, you're going to be, whoa. But there's no learning to it if you don't do it yourself first. And then when you see the solution, you're, oh, okay, that makes sense now. And then we can move forward from that. But you could cheat and wait for the solution, but you're really just cheating yourself, actually. So, okay, so in the third question, it says, draw a dependency diagram for the following situation, describing a database application for booksellers. So bookseller client who has the following requirement. I'd like my customers, and here's the interesting part. So the number 3 is written like a client. So they're not telling you all the different things. So number 1 was really straightforward. So number 2 is parts and parts and parts. Number 3 is about a description that some client's giving you about what the client, I want my customers to be able to browse my catalog of books and place orders over the internet. Wow, okay, well that doesn't describe my database, but okay. Currently I take orders over the phone. Do I really care about that? Not really. So parts of this description are kind of not needed. So I don't care that you take stuff over the phone. But I have my mostly corporate customers who call me and give me ISBN numbers, but I still need to use the system. So I might have input into the system that's coming from the phone. So I still need to accommodate that interface. I prepare shipments that contain books that have been ordered. If I don't have enough copies in stock, I have to order additional copies, yada yada. My catalog includes all the books I sell. And each of my customers are regulars. And my new website, customers should first identify themselves with a unique ID. So it's basically giving you a lot of information in terms of the design. This one's not too bad, actually. It's just figuring out what you're going to put in there. So, if you need a refresher on the syntax, this is primitive syntax, the one that we just used a few minutes ago, works out just fine. And the also beauty to this whole thing is that you can develop your own syntax if you want. Because really what you're showing is just the dependencies between the data. So if you find a tool set out there, which you don't necessarily have to use, you can do it, you know, like this, or you can do it with a tool set. It might be more complicated to use the tool set than it would be to use this, or to do it on paper. So you do not have to worry about submitting this right now. You can wait, but you want to work on it right now. And then I can take a look at what you've done and tell you if you're on the right track, which is a good part too. So go ahead, and we are here until 6. So we have another hour and 10 minutes or so. I didn't give you that much time, but you guys are going to want to practice a little bit here. We cannot leave until 6 p.m., but we can work on this stuff. So I'm going to stop this video.